Hello everyone. Hello students. Welcome to uh, the session of total stations. Right. In this total station, we will be studying about the components of the total stations, and we will be getting some components, and also we'll be seeing the various functions of these total stations in real. Okay, to the video. So before we start, we'll get to know about the total station. Actually, it is not needed because this has been done in your theory classes about the total stations. We have studied it, but once again, to brief you all, we'll go to the total stations. Use of electronic based surveying instruments is now become very popular due to the various advantages compared to the conventional instruments. The instruments, the recent applications of the electronics in the surveying precisions, then is possible using mechanical instruments. Okay, so this means that the electronically precision survey instruments are more advantageous for us than the mechanical uh, instruments, right? Total station can accomplish all the tasks, okay, that could be done with theodolite and do then much more and with more efficiency. In addition to them, they can also observe the distance accurately and quickly. Furthermore, they can compute it with the angles, distance observations, and display the results in real time. They not only just read the values, but they calculate themselves the distances. Whatever the calculation we do manually, it automatically does in its computer, and it shows there itself at that same point in the real time. Real time means at that present moment. Okay. So these are some of the components. That is telescope, right? This is a telescope, and the angle of measurement system. Okay. Then you have vertical circle. You have dual compensators, lock and tangent screws. These are lock and tangent screws. Here also it is there. Then you have tri-batch adjustment wheels. You have an optical plummet on that side, right? This is your telescope. This is your screen with a microprocessor inside, and there is a battery at this side. Here there is a battery. Okay, so these are the function keys which we are going to study, and there is an side it is has a mini USB interface and a SD card interferes. Okay, it has a battery for a power supply, and it has a electronic distance measuring device inside this telescope, right, which will help us to measure the distance and to process the data. We have a microprocessor in it. Okay, this is a target or a reflector. When you bisect the point, you have to bisect through this reflector or a target rod. Okay, this is called as target rod. So this is a function key, or a, you can say, screen over which you can see the various keys. That is, there is F1, F2, F3, and F4, and there are some angle buttons. There are some other buttons in blue color. Those are angle buttons and slope and vertical distances, and you have coordinates, and you have menu buttons. At the sides you have all the other buttons with the power button. Now we'll start with the button. When we press the power button, this is how it displays. Okay, and okay, you have the V, that is vertical angle, and this is a horizontal angle. These are the some of the setups. Okay, when you click on the F3, you will get northing, easting, and vertical coordinates. Now you have to put these coordinates into the computer or in theodolite before we start with the instrument. Okay, by using this keyboard. Now you can see we are adding as 25,000 meters. We are adding x, y, and z direction. So we have put the x. Now we just trying to randomly putting it. Okay. Once we are done with it, we can go to for height ht, that is f1 you have to press, and instrument height and the height of the reflector is to be added. You have to measure the height of the instrument and you have to add it here, because it itself processes the data and calculates. For that it requires height, so we'll keep it as 1.2. Okay, now you can bisect it using the f2 button. Can you see that bs button is there? You can see in the screen. You can set up it up. Okay, for angle you can set an angle and start measuring from there. Okay, if you say 0 degrees, it will start measuring from there and it will take that point as a 0 degree point. Here we are taking it as horizontal angle to set as 326 degrees point 23 seconds and 25 minutes. It doesn't require a dot after the degrees. Okay, if you it asks whether you want to hold that point or you want to change the angle. If you say yes, that angle will not change. If you rotate it, it will remain same. Okay, so these are some of the functions. When you bisect it, it will give the readings. Okay, using that you can measure. You have measure, mode, mean, and page 1, right? So using the measure button, you can measure the distances, angles of various lines. It will also give you the vertical distances. So once you are done with that, you can also calculate vertical distances, you can calculate horizontal distances, and you also can calculate the sloping distances. It will automatically calculate for you. So for each instrument company there is a different procedure. It varies from one instrument to another instrument. Okay, and also with one model to the another model. So it becomes difficult to explain all type here. We have just shown whichever we have a small brief introductions. When you go onto the ground, actually we'll be explaining in depth about those instrument, about those functions of those various parts. Okay.